All right, let's look at number 16 from our packet, SOAP exam practice problems. So again, I'll read it, you read it, push pause and solve it, and then come back and check. An insurance company pays hospital claims. The number of claims that include emergency room or operating room charges is 85% of the total number. The number of claims that do not include emergency room charges is 25% of the total number. And the occurrence of emergency room charge is independent of the occurrence of operating room charges on hospital claims. It's a lot of information. What are we looking for? We're calculating the probability that a claim submitted to the insurance company includes operating charges. So we have two events here. So E will be the event emergency charges, and O will be the event for the operating charges. All right, let's go back and see what we're given. The number of claims that include emergency room or operating room, so that's the union. So the probability of E or O is equal to 0.85. That's given in that sentence. The number of claims that do not include emergency rooms is 25%. So the probability of E complement is 0.25. And that quickly tells us that the probability of E, that is those that include emergency costs, is 0.75. And we're also given that the occurrence of emergency rooms charges and occurrence of operating room charges are independent of each other. So what does that tell us? Well, it's going to involve this union statement. So remember, the probability of the union of two sets is equal to the sum of their probabilities, and this is the inclusion-exclusion, minus the probability of their intersection. Now, we were told that emergency and operating are independent of each other, so that changes this to the probability of E plus the probability of 0 minus the probability of E times the probability of O. I said 0, but I meant O. And so we have the probability of the union of E and O is equal to the sum of the probabilities minus the product of the probabilities. And this we get from independence. All right, we know this value right here is 0.85 equals this one right here is 0.75. This is the one we're looking for, so we don't know what it is, minus, and then 0.75 times P of O. Now we just have to solve for P of O, and this is linear, so that's very easy to do. So 0.10 is equal to 0.25 times P of O, divide by 0.25, and that gives you 0.4 is the probability of operating charges. The answer is D. Did you get it?